This is a key to quiz number 3, and on quiz 3 you are asked to solve two inequalities, two linear inequalities. So here's the first one, and so you have 3x minus 4 is less than x plus 2. So you're going to solve, you're going to solve a linear inequality just like you would a linear equation, except remember with a linear inequality, if you multiply or divide both sides of a inequality, um, you have to reverse the inequality symbol. Now in this case, let's go ahead and subtract x from both sides. And so when I do that and then combine like terms, notice I am aligning like terms. So I get 3x minus x is 2x, and then minus 4 is less than x minus x is 0, and then 0 plus 2 is 2. So x and negative x are opposite terms, and so when you add them up, you get 0. And then the next thing you're going to do is you're going to isolate the term 2x. So you're going to, right now you're subtracting 4, so you're going to add 4 to both sides. And when I add 4 to both sides, these are opposites. Notice I'm aligning my like terms. A negative 4 and a positive 4 is 0. 2x and 0 is still 2x. Is less than 2 plus 4 is 6. And then the next thing you're going to do is you want to get x by itself. So right now you're multiplying by 2. And so the opposite of multiplying by 2 is to divide by 2. So let me go ahead and rewrite this. You can divide both sides by 2, just like this. And then 2 divided by 2 is 1. 1 times x is x. So you get x is less than. And then 6 divided by 2 is 3. All right, now what you found is this. So any number, any real number, irrational or rational, that's less than 3 will be a solution to this original inequality. That's what you found. All right. So, so again, any real number less than 3 will be a solution. Now there are an infinite number of solutions. So, you are asked to also graph the solution set. So since there's an infinite number of solutions, usually what's going to happen is you're going to be asked to graph the solution. So if I look at the graph, and let's say this is 0, 1, 2, 3. And since there's no equal sign, that means that 3 is not a solution, but any number less than 3 is a solution. So since there's no equal sign, you're going to put an open circle on 3, just like this, and then you want to shade in every real number that's to the left of it. So any real number shaded, all these numbers shaded, all these real numbers shaded, both rational and irrational numbers, will be a solution to the original inequality statement. So there's the graph. You're also asked to state the solution in interval notation. And so remember, when writing a solution in interval notation, always go from left to right. So use the number line that you just drew to help you. So when you go from left to right, notice that this arrow here is pointing towards that idea of that negative infinity. So you're going to say negative infinity with parentheses, comma, all the way to a positive 3. Now, since there's an open circle here, since 3 is not a solution, you're going to use parentheses. All right, now also remember that negative infinity and infinity will always use parentheses with it. All right, so that was number 1. So any real number that's shaded, any real number shaded is a solution to the original inequality statement. So notice that 5 is not a solution, right? 5 is not shaded. So if you substitute 5 in here, you'll see why. Watch. let's go ahead and kind of show that. So let's see why 5 is not a solution. Now that you're done with number 1, that's your answer. But I just want to remind you that any number that's not shaded is not a solution for a reason. So let's just check and see why x equal 5 is not a solution. Okay, so always go back to the original. So I get 3 times x, which let's substitute 5, minus 4, and I want to see if that's going to be less than 5 plus 2. All right, 3 times 5 is 15, right? And then 15 minus 4 is 11. And then 5 plus 2 is 7. So is 11 less than 7? And the answer is no. All right, so notice that any real number that's not shaded is not a solution, and it's not a solution for a reason. This statement will not be a true statement, okay? But every real number that's shaded will make this statement a true statement. This side will be less than that side. The left side will be less than the right side. All right, so that was number one. Now I want to show you this as well. So I'm going to do number one again, and you remember how in number one I brought all the variables to the left-hand side? You could have, if you wanted to, brought the variables to the right-hand side. So I just want to show you what would happen if you do that. So remember, when solving a linear equation or solving a linear inequality, it does not matter whether you bring the variables to the left or the variables to the right. It does not matter. So let's go ahead and do the same problem, but let's bring the variables to the right-hand side. So I'm going to go ahead and subtract 3x from both sides, just like this. And so notice I'm aligning my like terms, and when I combine like terms, 3x and a negative 3x are opposite. So when I add them, that's 0. 0 and a negative 4 is a negative 4. All right, so that's important. You saw that that's still a negative 4. It's less than x and a negative 3x. So remember, that's a 1x. So 1x and a negative 3x is a negative 2x, and then plus 2. All right, and then bringing the 2 to the other side. So I'm going to subtract 2 from both sides. And so a negative 4 and a negative 2 is a negative 6. It's less than a negative 2x. And that's 0 right here. Okay, now I got to get x by itself. So I'm going to go ahead and rewrite this over. Let me go ahead and rewrite that statement over. All right, so at this point, okay, listen carefully. So if I'm going to get x by itself, I'm going to go ahead and divide both sides by negative 2, right? But since I'm dividing by a negative number, since we are dividing, now remember, dividing by a negative number, we must reverse the inequality symbol. We must reverse the inequality symbol. All right, so I'm dividing by a negative number, so this inequality statement is no longer true. So I'm going to cross that out since I'm dividing by a negative number, and then I'm going to reverse it, so it should be greater than now. Okay. All right, now, so remember, if you have an inequality, and any time you multiply or divide both sides of an inequality by a negative number, you must reverse the inequality symbol. In this case, I'm dividing both sides by a negative number, so I have to reverse the inequality symbol. So here's what I have now. Negative 6 divided by negative 2 is a positive 3 is greater than, and then negative 2 divided by negative 2 is 1. 1 times x is x. So 3 is greater than x. All right, now most students, I shouldn't say most, some students have a little bit of difficulty understanding what this means right here, 3 is greater than x. They understand a lot better when x is on the left-hand side. See, they understand, all of you understand pretty well what it means that x is less than 3. You can see that. It's a little bit more difficult conceptually for some students to understand what this means. 3 is greater than x. So what you may want to do is rewrite this another way. So just rewrite it backwards. So 3 is greater than x means x is less than 3. So when you write it backwards, x is less than 3. All right, so those two are equivalent. And then from here, you would then graph it. So here's 3, here's 3 with an open circle going to the left. So there's the graph. And again, that's a 3 right here. And then again, interval notation, you're going to say negative infinity to 3 parentheses. All right. But the reason why I wanted to do this this again was to remind you about this part here. So when you divide or multiply an inequality by a negative number, both sides by a negative number, you have to reverse that inequality symbol. So cross this out and put greater than. All right. Okay, so that was number 1. Let's look at number 2. So number 2 in the quiz, you had this statement. This is number 2. So number 2, you had 2x plus 7 is greater than or equal to negative 3. All right, now notice that this one is simpler than the previous one in the sense that I see in the previous one, you had variables on both sides, constants on both sides, right? And so over here, you only have variables on one side. So it's easier. This is a lot easier than the first one. So it'll take you less steps to deal with. So the first thing you want to do is first of all, you want to get 2x by itself. So you're going to go ahead And since I'm adding 7, I'm going to go ahead and subtract 7 from both sides. So what you do to one side, you do to the other, just like you would an equation, a linear equation. And then notice I lined like terms, and then these are opposites. Positive 7, negative 7 is 0. So you want this to be 0 because you want to get this by itself. And now you got this by itself. So 2x and 0 is still 2x. It's greater than or equal to, and then negative 3 and a negative 7 is a negative 10. All right, so I'm going to go ahead and rewrite this over. So this is my statement at this point. So I want to, remember, I'm trying to solve this original inequality. So I'm rewriting it in equivalent statements to make it easier for me to solve for x. So at this point, I noticed that I can easily get x by itself. Since I'm multiplying by 2, I can easily get it by itself by dividing both sides by that coefficient. So 2 divided by 2 is 1. 1 times x is greater than or equal to, and then a negative 10 divided by 2 is a negative 5. So any real number greater than or equal to negative 5 is going to be a solution to that original statement. So if you want to graph it, so the graph would look like this. So let's say this is 0, and let's say this is negative 5. Since there's an equal sign, that means negative 5 is a solution. So you can put a closed circle on negative 5. And you're going to shade in every number that's greater than or equal to that. So you're going to do this. All right, so make sure you darken that shaded part and make sure you put arrows. And then interval notation. So your interval notation, you're going to say bracket negative 5 all the way to infinity. And notice, or always remember that whenever you're dealing with infinity, negative infinity, it's always parentheses, regardless of whether there's an equal sign or not. All right, so notice a bracket. There's a bracket there because there's a closed circle, meaning that negative 5 is a solution. All right, and so any number that's shaded is a solution to the original statement. And you can check a few. For example, let's go ahead and check and see. Let's check and see why negative 3 is a solution. See, negative 3 is shaded, right? Negative 3 is about here. Let's see why negative 3 is a solution. So why is x equal negative 3 a solution? So notice there's an infinite number of solutions, right? That's why you shaded in. You can't list them all. There's an infinite number. So you graphed it and you wrote it as an interval notation. This is my inequality notation right there. So let's see why x equal negative 3 is a solution. So always go back to the original. So here's the original. And you want to see that left-hand side is greater than or equal to the right-hand side. So where we see the variable x, I'm going to substitute negative 3. So 2 times negative 3 plus 7. And I want to see if that's greater than or equal to a negative 3. Well, 2 times negative 3 is a negative 6. Negative 6 plus 7 is a positive 1, right? And is 1 greater than or equal to a negative 3? And the answer is yes. So that means that negative 3 is a solution because the left side will be greater than or equal to the right side. Now let's check why. See, if it's not shaded, it's not a solution. So negative 7 is not a solution, right? So let's check and see why negative 7 is not a solution. So why is x equal negative 7 not a solution? So make sure you understand that. Why is that not a solution? So if you go back to the original, which is 2x plus 7 is greater or equal to negative 3, where we see the variable x, you're going to substitute negative 7. So you get 2 times negative 7 plus 7. And I want to see if that's going to be greater or equal to negative 3. Well, 2 times negative 7 is a negative 14. Negative 14 plus 7 is a negative 7. And is a negative 7 greater than or equal to a negative 3? The answer is no. Negative 7 is less than a negative 3. All right? So that's why negative 7 would not be a solution. So just to remind you about why it is that or what it means if it's shaded or not shaded. Okay? All right, so that's the key to that first quiz. So in that first quiz, most of you did it this way, where you brought the variables to the left. And then just remember, if you ever do it this way and you divide by a negative number, if you divide both sides of an inequality by a negative number, you have to reverse an equality symbol. And then on number 2, most of you did it this way, okay? If not all of you. Okay, so that's it. That's the key to number 1, to number 3, quiz to number 3.